and he thinks to keep me from burning out and to keep streams available because I can't be everywhere at once. We do need to find someone in each user group that wants to stream to train them, real simple, how this works and how to set it up, and make sure they have access to the equipment at 36, so someone else can set it up if I'm not available. So Dante's not here right now. I would assume he'd probably be down for doing that, but I don't know. It's between the two of you to figure out.
Okay.
But for future reference, we need to have that locked down before I do the next stream.
Okay. Sounds good.
All right.
All right. Let's see here. All right. Let's go ahead and go.
3, 2, 1.
All right. So today, what I want to talk about is my least favorite part of Arduino programming. Okay. So and that is event handling. Okay, and that's true for just about all embedded stuff. So I actually didn't bring my Arduino because I forgot a number of things tonight. But we're gonna play with Arduinos virtually today. So if you think about it, so what's the default way to make something blink in Arduino?
Delay.
Use delay. All right. So what's the problem with delay?
It stops everything.
It stops everything. So you can't be delaying for two different things. You can't have two different things going. Okay, so kind of our default thing we could do like a pin mode 1 output, and we could say digital write 1 high, delay 1000, digital write 1 low, delay 1000. That'll give us a nice blink. Okay, but the problem comes in as soon as we want to have a second one, pin mode 2 output, and let's say we want this guy to blink every 1.5 seconds, right? So if this guy has a period of 1 and this one has a period of 1.5, you can do something like, we can do digital write. So we 2 high, 1 high, delay 500, and we can kind of swap it back and forth. But you'd wind up having to do the least common multiple of both of those, that number of times, and that would be a huge pain in the butt. So usually at that point, and at every point after that, what people wind up doing is they wind up doing timers. Right? Some sort of counter, timer, something. So they'll either, one of the things that they'll do is they'll put in like timer 0, and then or we can say like int next blink 1 equals 1000, int next blink 2 equals 1500, or something like that, and then we say int time equals millis, and then we mod it for those numbers and see where we are in the cycle. And then if we're in the right spot, we'll turn it on. If we're in the wrong spot, we'll turn it off. Okay, and so that's kind of the next thing. But the problem with that is then you have all these timers. It's very opaque. And then if you wanted to have like some sort of a sequencing thing, so like you do this and then you're in this state and want to do something else. So then you have to have in your main loop a very annoying switch statement. So you have to wind up saying like int state equals 0. And so we say, if state is equal to 1, then do a whole bunch of stuff for state 1. So maybe in state 1, we're all blinking, and in state 2, we're not blinking, So, and so you have to have all these states in your loop. Or you have to have, if state 1, then call this, else call that. You have to do something that manages your state, okay? So all of this is horrendously annoying. I don't like to code this way. I come from, now I when I first started, I did assembly language. So I do have some sort of a soft spot for doing low level fun. But at the end of the day, most of my most productive programming has been when I've able to abstract this and like use Delphi or something. I use Rails in practice now. All sorts of things where you can kind of just say, when something happens, do this. Okay, so wait for something. So what would be really nice is if I could say, you know what, when we get to a second and a half, do something. When you get to when someone pushes a button, switch states. And when you switch states, here's a new set of things to listen for. Right? That's kind of what I want. Okay, so what I did is I implemented a library it's got a lot of limitations. So I'll tell you that up front. Mostly because of the SRAM limitations. It uses a lot of SRAM. And so after just a few, if you add on just a few too many events, it will completely destroy your SRAM. You'll be out of it. So the library is called Eventually. Okay. And you can get it on GitHub. It's actually on. There's actually a Arduino sketch for it.
I'm taking you offline for just a moment, because it's too hot in this room. This computer's overheating and is not streaming anymore.
Oh, we can.
Do we even have air conditioning on?
I think it's set to tone down.
Okay.
After hours.
Okay, yeah, because it's. Oh, it didn't go offline. Okay.
There it is.
Sorry about that.
That's cool.
I just noticed the fan was spinning like crazy. It's never done that before, so I was like, it's got to be too hot in here. And then,
So are we still streaming?
yeah, I
Okay.
tried to take it offline and I couldn't. It was so hot.
All right. So hopefully that'll cut it down. So, yeah. So eventually is my library to solve all these problems. You can get it in the. Let's see here. If you do include library, manage libraries, you can search for it. It's called Eventually, and 0.15 is the current version. So the way Eventually works is Eventually actually replaces your main loop. You could actually, if you need to do something in your main loop, Eventually is made to work with other things, so it doesn't have to be the only thing installed, but it also can be the only thing installed and makes your programming a lot simpler. Okay, so the way that Eventually works is you declare an event manager. Okay, so well, first you include it. So to do include library, where it is Eventually. Okay, so and then you create an event manager. Okay, so this is the guy that manages all the things. So then instead of your loop, you do this macro. So use Eventually loop mgr. And that will auto create a main loop for you that uses Eventually rather than the standard loop. So what you do is that in your setup, you set up the initial state. Okay. So the way we do this is with there. So Eventually has a number of things called listeners, and different listeners for different things. So here's a simple one that turns a light pin, that starts a light pin blinking if you push a button. So if you think about that, that's actually kind of an annoying thing to code. If I wanted to push a button and have a light start blinking, right, you'd have to have a state, and then if you push the button, it would activate the state. If you push the button again, it would stop the state. So you couldn't use delays, because if you push the button again, it would have to and you did it during a delay, it wouldn't pick it up. So you have to use timers and all that kind of stuff. And so this will actually, even in such a simple program, already gives benefits. So the way this is written, say pin mode 1 output, that'll be our light. Pin mode 2 input, and then we would just say in our manager, we do add listener. And here's where I break a cardinal sin of Arduino. I'll do new EVT pin listener.
Completely offline.
Completely offline.
Completely offline. Like it just gave up.
You broke a cardinal rule.
Yeah, you said here we break a cardinal rule, and YouTube's like.
You told them that we're having technical difficulties and it's being worked on?
Mm-hmm. Well, they probably saw me go and mess with the thermostat.
I am now. The YouTube offers broadcast alerts, and one of them is explicitly, we are experiencing technical difficulties. Please stand by.
I'm going to need you to come do some of the Java ones when we have an actual topic set up that's worth doing.
This is why we absolutely recommending you have Ethernet access, because this sort of thing kills the stream when Wi-Fi starts.
There's a wired Ethernet port right there going to the main computer at the teacher station. I've used it before.
Darren's told me about this, and he was curious if that would have worked out. Is this gray cable hooked up to Ethernet directly by any chance?
There's an Ethernet port it's connected to.
Maybe. What is that?
It goes to the phone.
Oh yeah, probably then. I mean,
doing
yeah,
voice
because
over
this,
IP,
yeah, we're doing.
And we have a full signal again.
Woohoo! Back up.
Yep.
Yeah, we're online.
CPU's at 15%. Yeah, we should be fine now.
Okay.
Probably run a heck of a lot cooler too.
Yeah, well, it was only running 20%, so I can't imagine that would have been.
Yeah.
Oh, I have to turn that off.
Are we streaming?
I'm waiting for YouTube to say that yes, we're streaming. Because YouTube says we're not streaming. It's just yelling at me, going bad, bad, bad.
I've never
Did we-
understood how this could possibly work. I mean, that's just...
Did we lose the people who were watching us?
No, they're still watching.
Oh, nice.
Just tell them you got to reboot the world.
You know, a lot of video podcasts are now done this way, with no editing.
Oh yeah.
Just directly streaming to
Mhm.
YouTube.
It's actually pretty easy to do.
Yeah.
Just with a computer.
It takes a lot less time than putting together a well-crafted podcast.
Yes.
So it's actually editing.
Well, what I usually do is I usually just record my Keynote presentations from Keynote, and then just convert those to videos, because that's super simple.
Well, YouTube says it's not working, but I'm getting the video up. You're there. You're talking.
I'm on YouTube.
You're on YouTube.
Oh wow.
You're live right
Hello,
now.
people on YouTube.
Do you have like an IRC channel where they can give you feedback and ask questions and stuff like that?
They could just post a comment on YouTube because it supports live comments.
So since
Alright.
we're now live, theoretically, and
Hey,
audio,
so do people on YouTube? Do you all see me? We're trying to figure out if we're actually on. Any response?
It takes a few moments before the stream catches up. And if they say anything that's a bannable offense or a blockable offense, their message will get blocked. So
Fair enough.
it'll be offensive.
What if we say something that's bannable?
Community strikes are really bad. It means no streaming. Like apparently it's really bad.
So this is the official test of whether we're on YouTube or not. Go to YouTube and look.
Yeah.
Yeah,
Go on your phone.
is what I am doing now.
so I'm bummed. I was going to actually plug this in and try to do some stuff, but I don't have my power brick with me. I've got one at work and one at home. And apparently this particular computer, I put into my bag sleeping as opposed to shut off.
Yeah, you're live.
Okay, great.
YouTube's just lying
YouTube
to
just
us.
is lying to us directly. All
Yeah,
right.
YouTube says you're wrong, and
All right.
YouTube's wrong.
So what we're doing is so what this is going to do, we're going to add a listener. Okay, and so this
Might want to back up
Yeah,
like
so
3 statements.
Right. Okay,
because
so
we lost some of that.
Right. Okay. So what we're doing is we're doing the event library. We're replacing our event loop with eventually's event loop. And so what we do is so what this program is going to do is you're going to push a button and it's going to start a light blinking on and off. You're going to push it and it's going to stop it. And it's already annoying to do that because if you think about it, you have to push a button. You can't use delays because if you push the button during the delay, it's not going to trigger it correctly because it's delaying and not doing anything. Additionally, you've got to have the timing for turning the light on and off. There's even another, even more annoying thing, which is bounce. Everyone here know what bounce is?
Yep.
Yeah, so you've got the bounce in that when you push the button, you're not just pushing the button. You could be pushing the button at some point. You could be doing all sorts of things. And so then you need even timers for your timers to know whether or not you have bounce. So you basically see if you have the button pushed down for X number of milliseconds consecutively, or you have it let up for X number of milliseconds consecutively.
I thought the Arduino, if you switched it to pin mode input and then set the pin high, I thought Arduino's automatically took care of bounce by adding a small capacitor to the end.
It is possible. I am not familiar with that. That would be cool.
Sounds like a side with
I mean, usually they don't put capacitance in ICs, but it's possible someone did something. That would be pretty impressive. If you have a chance, look that up while we're talking. But anyway, even if you had so this library, yeah, maybe we don't need all of it for Arduino, but nonetheless, the idea is that we can encapsulate all of this intelligence in a single listener so that the programmer doesn't have to worry about that. They can just do the things. Okay. So what we're going to do is eventually has all these types of listeners for different things. So one of them is a pin listener, and so the first argument is the pin. So it's going to listen on pin 2, and when pin 2 gets triggered, it's going to call a function called start blinking, and that EVT action is just casting it. So this is basically all you do to get started. You just add a pin listener for this pin, and it'll call this function. So now we need that function. And so here's the function. I'll go ahead and add it in here so we get some. So the start blinking function. So what it's going to do, so the first thing it's going to do is it's going to reset the context. And what that means is it's going to tell so reset context tells the event manager to just ignore, to clear out its whole queue. Because right now it still has a pin listener registered for us. So it says remove all your listeners. We don't care about any of them. So then we're going to register 2 more listeners. We're going to register a listener. That's going to be a time listener. And so this guy, every 500 milliseconds, is going to call blink pin. Okay, every 500 milliseconds. And then we're also going to add a listener, and that true means to keep firing every 500 milliseconds. So if you set it to false, it'll wait 500 milliseconds, fire, and then stop. So by setting it to true, it means that every 500 milliseconds, we're going to get that firing. So then we're going to add a listener for the pin. To T action, stop blinking. Okay, so now we have 2 listeners. We've got the time listener and we've got the pin listener. Okay. So now what we need for blinking is just we need to have a blink state. That's going to be its current state. And then blink pin. It's going to flop the blink state.
You missed a P there.
Thank you. Blink in. It's going to flop the blink state, and it's going to digital write our output pin with the blink state. So every 500 milliseconds, it's going to call this. It's going to check the state and flop it, and then write the new state to it.
What's the return value?
That's your. Yeah, it's event chain. So if there's multiple chains, multiple things registered, it's not like don't run anything else. It means you can go ahead and run the other things in your event loop.
Oh, so it's a halt the chain here.
Yeah.
Okay.
Yeah, if it was true, it means halt the chain. So and then stop blinking does exactly the same thing, just the reverse. Just does a manager reset context, manager add listener, VT pin listener, to EVT action, start blinking. So anyway, as you can see, I mean, this actually might be slightly more code, although I think with once you add debouncing, it would be about the same amount of code. Slightly more code, but it's infinitely more readable. It's infinitely more obvious when you're traveling through the code what this is supposed to do. You don't have to worry about counters. You don't have to worry about bouncing. You don't have to worry about anything. You just set what you're listening for, and you set the state. And so as you can see, we're traveling through states. We're going from start blinking to stop blinking, and from stop blinking to start blinking. So we're traveling through states, but we don't have to have a big switch statement to do so. It's all being managed by the event manager. Because in fact, we don't even have our main loop. The main loop is handled by the event manager. So that's kind of the basic idea of it. Any questions on the basic idea? I've got another example to show.
Is there an option to continue using your own main loop and just trigger it one at a time?
Mm-hmm.
Okay.
So what you can do for your own main loop, where is it? Because this is just a wrapper. All you have to do, I forgot what it is. Hold on, it's in the source anyway. Source eventually use main use eventually. Oh, it's in the header. That's what it is. That's why I can't find it. Yeah. So all it does, it just calls this. And so that's what that macro does. And so all you have to do if you wanted to do something else, if something else required the main loop, you would just do this. You just put whatever you want right there. And then as long as the loop is whatever's in there is short acting, you know,
or at least doesn't delay.
Right. As long as it has a reasonably short time period, then it'll continue to work. So anyway, so you can.
Could this also be a way to intentionally stop the loop manager if you wanted to?
Yeah, I guess so. You could. Yeah, if you just didn't call it. The one exception to that is I've thought about adding some additions to this, so that it would trigger like the internal timers and stuff like that of the Arduino. Because right now it just calls millis to find out how long we've waited and stuff like that.
I know some libraries co-opt those for hardware purposes, like for SPI and whatnot.
Yeah. So I've thought about doing that, but I haven't for some of those reasons. Using interrupts for the pin triggers, all those things. But at the end of the day, I think just to make a simple, straightforward thing, this is pretty good. So what I did on this is I used this to make a tennis game. Okay, so this is So I can't live code it because it's a little long. But if you actually look at it, if we just scroll through it, so what it is it's 2 buttons with a bunch of lights in between. So you push the button and the lights go across. Push the button, it goes back across. But if you don't hit it at the right time, you lose. And I'll give you a little blinky. Say,
You want a way to virtually show this?
I don't have a way to virtually show this, unfortunately. But that's what I'm describing.
Is this also known as 1D Pong?
1D Pong, yes.
Okay.
So that would be a good way to describe that. So
Greg's got it as well.
I was going to say, I think there's actually several instances of 1D Pong.
He's a mechanical, I mean, an actual
an actual physical one?
Right.
Nice. So the nice thing, if you look at this, it is not a lot of code, right? So it's pretty. Just before we actually look at what it is, it's a pretty small. It's pretty straightforward because you'll notice there's no real counters in this either. So it's pretty minimal. So basically, if you think about it, so what it does is it's got a couple defines. It tells you what pins the buttons are on, where the ball, which is the lights, what pins they're on. So you could actually add more lights if you wanted to, just by changing the start and end. So if you wanted to have 20 lights and you had a mega, you could just increase the number of pins in between the start and the end, and it would automatically accommodate for that. You got a ball speed, and then I think this is just how long it takes to reset between a you lost and starting again. So so basically, when you set up, obviously it sets the inputs, and then it sets the current player to 1, and then calls ready player. And what ready player does is it first resets the context, so any listeners we had, clears them out. And then if the current player is 1, it's at position 0. If it's player 2, the ball starts on the other side. Okay. So then we call show ball, which just turns on that light and turns off the other lights. And then we add a pin listener, because all we're waiting for it now is for the player 1 to push his button. Okay, so that's what it is. So when player 1 pushes his button, we do start next player. So show ball is here, and all it does is looks for the current ball and turns all the rest of them off.
So player 1 always starts?
Player 1 always starts. So start next player. Again, so once you push that button, it resets the context because we're going to do something new. It adds an event listener for the time. So however fast the ball speed's going, that's so you can actually technically decrease ball speed, because that should be ball delay. It's a better term for that. And that will call move ball every X number of milliseconds. So move ball is happening while everything else is happening, and we don't have to do anything funny to code for it. So here we switch the player. If it was 1, then it's 2. If it was 2, then it's 1. And then we listen for that player's button. So basically, we're not listening for the other guy. The other guy can push his button all day long. We don't really care. So we're just listening to the other guy's button, and when he pushes the button, we'll call swing racket. Okay, so 2 functions could be called at any given time, either move ball or swing racket. Okay, so if move ball gets called, all it does is it moves the ball position. It either increases or decreases the ball position based on where it's going. And if it goes past the right position, we call missed ball. Okay, and all missed ball does is blinks at you and then starts over. And then it shows the current ball position. Okay, so then swing racket, it determines if you hit the ball or not. Okay, so if the current player is player 1 and the current ball position is 0, you hit the ball. Also, if the current player is 2 and the current ball position is at the end, you also hit the ball. So congratulations, you hit the ball. Otherwise, you missed the ball. Okay, so hit ball, it just calls start next player, which basically switches who the current player is. We're just going to switch which direction the ball moves. going to reset who it's listening for. If you miss ball, it'll reset the context because we're not listening for anything. Turns over. Show all turns all the light pins on. So it says, sorry. Sets the current player to 1, and then adds a delay for when it's going to go back to rest. Okay, and so this one we trigger with false because we only want that to happen once. We don't want it to keep on triggering. And so that's the whole program. So as you can see, it's very so this takes a tennis game and just makes it super straightforward how it works. There's no funny state management. There's no weird things about which pin is allowed to be pushed, which pin shouldn't be pushed, which pin are we listening for. It's all managed by the manager, which we can set with the state. So anyway, so as I said, the problem with this comes with this guy, new. And so the problem with new in Arduino is that new allocates a lot of memory to the SRAM. You start using heap space instead of stack space, which the Arduino really doesn't like. And so you very quickly, I think, because what I tried to do on this is have like context pushes, so you could push a context, and so you could then return. So if you think about like a menu system, you could like push to the next menu, and when you're done, you push back, and then just restore the context. But
pushing type operation.
Yes, and so I put that in there, but I think as like at 2 levels deep is like, I'm sorry, that's all you have.
I wonder if that depends on which Arduino you have.
Most of them have all of them have very small SRAMs. I forget what the actual number is. Anyone remember what the number is?
I'm just thinking like the Mega.
It didn't have a lot more.
No?
No. It has a lot more flash memory for the actual program, but the data was not that much.
More flash and more pins.
More flash, more pins, not a lot more data. It might have a little bit,
I
but
wonder if then something like
The
this.
Uno has 2 kilobytes. The Megas both have 8 kilobytes.
yeah. So
You've got 4 levels deep.
yeah. So you've got 8K of RAM, and if you think about these objects, these are, C++ objects are pretty stout. I don't know how much it actually strips off of them and how much you could get it to strip off of them. So we are using the Vtables. We're using Vtables for this. So for those of you who don't know, Vtables are how object-oriented programs allow you to use one thing, like basically, so all of these are listeners, but they're different kinds of listeners. And so the listener knows how to manage itself. The library doesn't have to know how the listener works. And so, but to manage that, you have a second set of indirection, which is tables about what your object is. And those add a lot of memory, and then creating objects that use those take up a lot of memory. I don't actually know how much. And then also just using getting heap space, I don't know when that thing even bothers to reclaim space. Like if I delete something.
You have to manually delete for it to reclaim.
Yes, I do actually delete. So the deletion, because one of the goals of Arduino is so that users do not have to know how C++ works. Right, that's one of the goals. And so even though I included new, I tried to follow the users don't have to know how C++ works.
So does this mean you're not going to explain how your library works?
What?
Well, how does the library code
Yeah, I'll show that in a minute.
deal with this stuff?
Yeah, I'll show that in a minute.
Okay.
So memory management is awful, and so rather than making users do memory management, they have to know to use the new keyword, but they don't have to know that they need to delete stuff.
Okay.
So I've tried to make it so that the library will manage the deletion. You just have to create it. Okay, so that way It mostly follows Arduino's rules, but not 100%.
In one sense, though, it breaks the best practices most developers follow, which is the thing that creates the object should be responsible for deleting.
It does. It does. Thankfully, these are also pretty small objects. So, and we're in embedded environments where the rules are always a little bit different. But anyway, so it follows one rule to break another. So I don't know if that's good or not. So yeah, if you want to see how this thing is implemented, it's actually pretty small, pretty straightforward. So here is the header file.
And this is your library?
Yeah. So let's see here. And this may be just as a note for anyone looking at this. I had a version that I was working on. I haven't looked at this in a while. I had a version I was working on that didn't quite work. So it's possible that this particular version we're looking for has some bugs in it. But I think the one that I pushed to the Arduino system does work. So if there might be some bugs. So basically what you do is you declare a class, and so this is our manager. And it has a stack of contexts, has add listener, remove listener, and then this is the push and pop, which I said you can't get very far on it. So the context has setup context, loop iteration, which handles every time it goes through the loop. The context itself has add listener and remove listener, and then it has a pointer to the actual listeners, and then a count of the number of listeners that we have. And I think somewhere I've got a max listeners. Yeah, so I've got max contexts and max listeners. That way we don't have to use any array libraries, but we have some of the benefits of dynamicism and some of the benefits of staticness. So the listeners themselves, so this is basically the contract for someone who's implementing a listener, okay? And so basically they get the action that gets triggered. You can put extra data on a listener if you want. Then setup listener gets called when it gets registered, I believe. And then is event triggered. So every time through an iteration of the loop, it goes to the current context and asks each listener if it was triggered. Then it's the responsibility of the listener to say yes or no. Okay, so you can be triggered by anything you want. You just have to respond correctly to is event triggered. So like on my pin listener, there's a debounce switch in the listener, and so the is event triggered will check whether it was it pushed down for long enough, all those sorts of things. All those are handled in the listener, and then the perform trigger action. I think there's a default implementation of that, and most of them just do that. So usually the only thing that you really need if you're implementing a new listener is event triggered. If you override that function, that will do what you need to do. You can also override setup listener if you need to do any setup actions, and then the rest of it takes care of itself. So my pin listener, so it's going to have what pin it was on. So first of all, it's going to have some constructors. So these are how they get created. I can do just the pin and the action, or I can do a pin, whether or not I want it debounced. And actually, I think that's a quantity for how long to debounce. And an action. So the information I'm going to store is the pin, the amount of debounce, whether the target, whether I'm listening for a high state or a low state, and whether or not it has to start in an opposite state. Right? So like if I say must start opposite equals false, that means if I'm waiting for the pin to be pushed, waiting for the pin to be high, and it starts high, it's going to wait for that to go low first before it triggers. So must start opposite, and what is the start state, and when did I first notice that anything happened? So
what is that in
I think it's milliseconds. So then I have a time listener, and it's basically, this one's simpler. It's I've got when the starting time was. So setup listener is going to set the starting time with this guy, and then whether it's going to fire more than once and how many times it's fired. So that's the header file, and so the implementation file is similarly pretty straightforward. Most of the event manager is just managing pushing and popping contexts and pushing and popping listeners. That's almost all it's doing. Doing destroys and doing the loop. So in a context, all the loop iteration does is it goes through each listener, asks if it's triggered. If it's triggered, it runs perform trigger action. So let's see here. Let's go back to let's go down to the actual listeners. So the default implementation of is event triggered is just to return false. No, we weren't triggered. The default implementation of setup listener is to do nothing. And the default implementation of perform trigger action is to call trigger action. So you don't have to overwrite this if you don't want to. So here's what the pin listener does. So the constructor just sets the initial values, and the setup does a digital read on the pin to see what the start state is, because that's why if you were already pushing it and you want to make him let go first, we need to know what the start state is. So when we set this up, we find out what the start state is. So on is event triggered, so this is going to be run every time through the loop. Is event triggered. So if there's a first noticed, so if we've already noticed this check, it's going to go and check to see if it's been pushed long enough. And so if it has, it's going to return true. Otherwise, it's going to return false. So here we return false because it wasn't active, and here we return false because we're waiting for it to finish debouncing. We're just waiting that time out. So that's the debouncer. And then here is, and so the nice thing, we only have to write that debouncer once. And then here's how it is initially triggered. We check to see if we must start opposite and the start state was the target value. We see if we can identify that we've changed. If we've changed, then we say, okay, we've changed. Otherwise, this is the real deal. Is the value our target value? If we set no debouncing, we can just return true. Otherwise, we mark the time when we first noticed it and return false. And if it's not the target we're looking for, we return false. Okay, and so that's the pin listener. So the time listener, super simple. When we set up the time listener, it figures out what time it is, and then we just check the time every time. Every time we run through is event triggered, it checks the time, and then if the current time is greater than the start time, let's see here. If the current time minus the start time is greater than the number of milliseconds, then we should fire. Otherwise, I think this is a fix for if you happen to be in the situation that because there's actually I think after X number of days that millis actually wraps around. And so if you happen to be in the exact situation where millis wraps around, this will actually cover it.
What are millis?
Millis, milliseconds.
I know, but what actually?
So that's from the time of boot. So how many milliseconds from boot time?
But this is produced in the code, or is it
millis?
the processor?
Millis is a standard Arduino function, and it's done. I think it's the processor itself. It may be the Arduino
So
system.
it's just a counter,
Yeah.
basically?
Mm-hmm. Number of milliseconds since boot.
There's a clock function in the Arduino that just flips over and updates the time.
Yeah. And
It's
so
not super accurate, but it's very close.
Yeah. So but as I said, I think it's just a straight int And so
I
after,
think it's a long.
well, there's a wrap time
Yeah.
at some point, and so yeah, it is a long because that's unsigned long.
So you're not using any interrupts for this,
No.
just following the clock, basically.
Yep.
Keeping track of whether
Hmm.
something started or not.
Right. Yeah. And so yeah.
And
so-
that's why you can do multiple things at the same time.
Right. Exactly.
Without having to
You could,
figure out
you-
how they would work.
you could do this with interrupts and those things. You
Yeah.
could do this. It would be a lot harder to code, but the nice thing about this is that it wraps it sufficiently that you could do that and the programmer wouldn't have to care.
Yeah.
So then, whether or not it should fire, it returns should fire. So anyway, if we're on multi-fire, so if we perform trigger action, this has a little bit different code. If we're on multi-fire, it resets up the listener. Otherwise, it just returns the return value. So that's what that does. So anyway, so so as I said, you can do anything with this. So you could layer things that rely on other protocols on top of this. So if you had something, you could wait for something to be received via serial. You could wait for something to be received via I2C. All sorts of things could be layered on top of. You could layer this on top of it just by creating a listener for whatever it is you're looking for, and when you get it, and so you can just register the listener, and it all goes swimmingly.
So it just checks each listener
Mm-hmm.
over and over again.
Yep. Which is exactly what you would do if you did it in the loop.
Right.
So, and it only checks the active listeners.
Right.
So once you do reset context, it clears all the old ones out, and you just add new ones.
So why does it need so much RAM?
Because of the C++ objects. It uses C++ objects to
So if you were doing this in assembler, it would not take.
But the problem, I mean, you could do it in less room. You still have some overhead in that this works by indirection, because the main loop doesn't have to know what your procedure is for checking, for setting up, for checking, and for performing the action.
Right.
So what you basically do is you could give it a tuple of probably 5 ints is probably what you need at least per event. At least 5 ints. And then maybe more, because then you have the data for each one, so then you have to have the size of the int. And so that's where it gets, at some point you cross over between you're saving space by using C or assembly versus you've just increased your complexity to where you might as well almost just be using C++ anyway. So I don't know exactly how thick the C++ objects this generates are. That'd be an interesting thing to look at. I don't know if there's a way to slim them down either. That might also be an interesting thing to look at.
The other thing about doing that, as well as with using the built-in timers, is this, at least from first glance, appears very cross-device
Yes.
compatible. Whereas if you're using timers, you might override a timer that's necessary for that chip, or
Right.
the timer may not exist because you only get one or
Right.
none.
Yeah, this should work for any Arduino compatible thing at all.
So I'm kind of wondering what the RAM is for this. This is the ESP8266, the Node MCU, the big boy.
Yeah, so for anyone who's checking RAM on any chip, it's the SRAM that you're concerned about.
Right. Give you the exact. So specifically, this is the.
It's not directly comparable because that is a 32-bit processor, whereas the Arduino is an 8-bit.
That's true.
So
you're gonna
the
have
two
different
values are
sized-
different.
You're going to have different sized
It's
objects.
an 8. ESP8266.
But I'm still curious what it is.
So an STM32, if you, I don't know if they make Arduinos with that, but they make similar things.
Yeah.
That would give you a lot more resources to work.
Well, so the 32-bit. The problem with those is that the objects are bigger,
Okay.
so you actually can
Because
wind
they're
up with
all
left.
32-bit.
Exactly. You have now. If you manage to have a RAM chip that was offloaded, that was off the chip,
Yeah.
that would, then all of a sudden it's not a problem anymore.
Okay, it's 80 kilobytes, but it's a 32-bit processor, and it's not true SRAM, so it's structured differently. So the value is non-comparable because some objects will be larger and some will be the same size. So depending on how the code is structured, determines what your actual available object size is.
That's interesting.
So,
All right.
because this is DRAM that's inside the ESP.
But for the purposes of what we're trying to do, they are comparable in the sense that this is the RAM that would be used. Just like the SRAM would be used on the
Well, the DRAM can end up using larger amounts for certain things.
I get that a 32-bit object takes up more space than an 8-bit object. What I'm saying is, what is SRAM on the Arduino would be put into DRAM on this particular setup.
On this particular one, I have no idea.
Yeah, I think you're right.
It's just the memory architecture that's used by the chipset.
Right.
Well, it also depends on how this is compiled, so your compiler is going to matter.
No, but the RAM
But
is the RAM.
I don't think the compiler actually knows what kind of RAM you're.
No, it doesn't, but compiling two different compilers can end up with two different sized objects for the exact same
Right.
code, regardless of
Right,
architecture.
so I'm not quibbling about the size of the object, I was simply quibbling about where it's put. It's put into RAM.
Yeah.
Right.
So we've got 80K of RAM. So we've basically got 10 times the mega.
Right, but my objects might be 4 times the size.
Right.
Right.
So.
Also, more stuff is put into this RAM than, your program is actually loaded up into this RAM.
Oh, it is.
Yep. So you actually end up with 32 kilobytes of instructional flash RAM, but all that gets piped over as you're executing to
Gotcha.
the actual RAM.
So you've basically got 40K.
Depending on how your
Yeah.
program's structured. So you can structure it in a way where only part of it's loaded at a time.
Gotcha.
Like if you use, on strings, normally strings are loaded into RAM, but if you use program mem
Right.
identifier, it puts it in there. That's not necessarily copied over,
Gotcha.
except when the string is being used.
Gotcha.
So it has 32K of instruction RAM, 32K of instruction cache RAM, 80K of user data RAM, and 16 kilobytes of ETS system data RAM.
Interesting.
All of which could, depending on how the program's structured, end up inside the user data, inside the cache.
Yeah.
Kind of depends.
So that would be interesting.
If it's well optimized, you get
Yeah.
quite a bit because that instruction cache RAM is where you're going to do most of
Mhm.
the memory storage. So,
All right. So do we have anybody still online with us?
Put them all to sleep.
Did we put them all to sleep?
looks like the people are still watching.
All right. Well, I'm gonna pimp my book then. Anybody watching? Calculus from the ground up. New calculus book. It's awesome. All right. So, any questions from
Available
YouTube?
where? You got to say where.
Oh, it's on Amazon.
Okay, but
Yeah.
you have to say that.
Well, it's a book. It's on Amazon. Find it on Amazon or Barnes and Noble if you prefer.
Oh, you managed to get it on both?
What?
Oh, you got it on both? That's
I presume I haven't actually checked Barnes and Noble, but Lightning Source usually is the printer I'm using, and they manage distribution, and they're usually pretty good about getting it on pretty much all the online places. So.
I'm not seeing any questions online. So.
All right. Well, thank you all for joining us. Appreciate it.